Hey everybody, good morning. This is Mr. Ainsworth. We're going to get into your homework here on recursive sequences in section 9.1 in modern math, or what's called discrete math. So get your calculator out and also get your red pen for annotating and correcting, and correct your homework, or just get some help on your homework. I sure hope you tried each one. So correct it first. All right, just don't sit here and copy, but go ahead and correct it and learn from it and learn from your mistakes. Okay, so here we go. I already explained number one, so we're going to go to number two. The very first thing I look at is like what's happening from 2 to 9 and from 9 to 5 and so on. And so let's look at some patterns here. So here I see plus 7, and here I see a minus 4. And here I see a plus 7, and then here I see a minus 4. So the next one should be a plus 7, right? So this should be 15, and then here should be a minus 4. So 11. All right. Now because it's not the same common difference all the way through, it's not arithmetic. All right, common difference is not in common. It changes. The difference here is 7, then negative 4, then 7, then negative 4. So it's not arithmetic. Okay, not arithmetic. And because you don't multiply something, the first term by something to get to the second term and keep it constant, it's not geometric either. So it's neither one of the two. So the pattern once again is plus 7 minus 4, plus 7 minus 4. Last two terms 15 and 11. All right, number three. Number three should be a little bit different here. What do you do from 4 to negative 8? One way is to subtract 12. All right, minus 12. 4 minus 12 is negative 8. But negative 12, negative 8 minus 12 again will give you negative 20, and we want 16. So it's not arithmetic. So the difference is not in common because this is something different here. We'd have to add 24 to negative 8, and this is plus 24. So there's no common difference here. Okay, so it's not arithmetic. So it's got to be geometric. So let's try geometric here. Let's take the second term divided by the first term like we did. Let's check the common ratio here. So negative 8 divided by 4, that's negative 2. Let's call the common ratio, as I talked about earlier in the lesson. Let's see if that works. So times, let's say multiply by negative 2. So times negative 2 again, get negative 8 times negative 2 is 16. 16 times negative 2, again, multiply by negative 2. And then again, multiply by negative 2, you get 64. And then multiply by negative 2 again. All right, you get negative 128. So it sure looks like it's geometric. All right, common ratio is negative 2. I found it by taking the second term divided by the first term. Last two terms are 64 and negative 128. Now, because it's geometric, you can write it recursively. So since a sub 2 is equal to negative 2 times a sub 1, I can say in general that a sub n is equal to negative 2 times the previous term, a sub n minus 1. All right, there's your recursive definition, or a recursive rule. Okay, there we go. Let's go back up to number 4. There we go. All right. Now I see a pattern in the numerator. I see these are powers of 3. This is 3 to the 0 power. This is 3 to the first power. 3 squared, 3 cubed. And so the next one should be 3 to the fourth. Or you can say, hey, multiply by 3. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. So here I can simply multiply by 3, the numerator, and I get 81. So 81 up top. Down below I see plus 2, plus 2, plus 2. So numerator times by 3, denominator, add 2. There's my pattern. It's neither arithmetic nor geometric. And I get 81 17ths. And then I have to times by 3 again up top, and I get 243. Add 2 below, and I get 19. So 243 19ths. Okay, so I got my last two terms. But that's neither arithmetic nor geometric. It's just a crazy pattern. Okay. Next one here, I'm decreasing here, so I'm going to try to find a common difference here. So I'm going to see if it's arithmetic. So negative 31.5 minus a negative 23. All right, negative 31.5 plus 23. If you don't like doing it all in your head, use your calculator if you like, but try subtracting the terms to see if there's a common difference, to see if it's arithmetic, and see what you get. So open up your calculator, turn it on. We're decreasing here, so I'm going to try subtraction. So negative 31.5, okay, minus a negative 23 is the same as plus 23, so plus 23 is negative 8.5. So what's going on here is this. So I'm subtracting 8.5 to get to the next term, minus 8.5 to get to the next term, minus 8.5 to the next term. So it is arithmetic. There we go. And I subtract 8.5. So what I'm going to do is I'm going to enter in my last term given, negative 48.5. There we go. Minus 8.5, minus 8.5. And I get my next term, which is negative 57. So negative 57 here. And then I got to subtract 8.5 again. So minus 8.5. Again, I get negative 65.5. So negative 65.5. Now my recursive definition is this. So I take the second term was the first term minus 8.5. The previous term minus 8.5. So in general, I can say a sub n is equal to the previous term, a sub n minus 1, which is the one before a sub n, minus 8.5. Here's my recursive definition. All right, the next one. Next one's decreasing too, but by a lot. This one you have to subtract over 1,000. This one you don't have to subtract as much, so it's not arithmetic. So it's probably geometric. So I probably have to divide by something. So let me check. Let me clear out my calculator here. I'm going to take 1,620, and I'm going to subtract the 540 to see what my difference is. So, excuse me, not subtract, but divide. So divide by 540. I get 3. Okay, so the second one is the first one divided by 3, which is the same thing as multiplying by a third. And then 540 divided by 3 equals 180. Divided by 3 equals 60. So it looks like we're dividing by 3 or multiplying by a third. So R, the common ratio, is 1/3. Divide by 3. Okay, so here we go, divide by 3. Divide by 3, you get 20. Divide by 3, you get 20/3. Okay, so the second one is found by taking the, hang on, let's try this again. Give me a second here for my computer to catch up. The second one is found by taking the first one and dividing by 3 or taking a third of it. So that's a sub 1. In general, I say take a sub n, or any of the nth term here, any term I want, is found by taking the one before it and dividing by 3 or multiplying it by the third. All right. When you multiply by a third, you're dividing it by 3. Another way to write it is take a sub n minus 1 divided by 3. You can write it like that too. Or you can take a sub 1 divided by 3 like this. You can write it either way. All right, number 7. Oh, I'm going to think addition first, so I'm going to see if it's arithmetic. So here I add 9, and here I add 18. Okay, so it's not as simple as that, so there's no common difference, so I'm going to try a little bit of something else. I'm going to try a little bit of multiplication here. If I multiply 7 by 2, I get 14, and then 14 plus 2 would be 16. So maybe I double, so times by 2 and add 2, add 2. So 16 times 2 is 32, plus 2 is 34. So it's working. So the pattern in this case is multiply by 2 and add 2. So here we go. I'm going to enter in 142, my last term. So 142, I'm going to double it, so times 2, and then I'm going to add 2. I get 286. So 286 here. And then I'm going to double it and add 2. So times 2 plus 2, 574. So it's not arithmetic because there's no common difference. No common difference. Okay, not arithmetic. And it's not geometric. Okay, not geometric because there's no common ratio. No common ratio, not geometric. Okay, on the next one here, what do you add from 3.5 to get to 4.7? So I don't know. Let me check here. So on this one here, let's take 4.77 minus 3.5, and you get 1.7. Excuse me, not 1.7, 1.27. So let me change that. Okay, so we get 1.27. So here you add 1.27. I found it by subtracting. Let me write that down. So 4.77 minus the previous term, 3.5, equals 1.27. That's how you find a common difference. Take a sub 2 and subtract a sub 1. Okay, but let's check it. Let's take 4.77 and add 1.27. Whoops. Got to put the right numbers in. I get 6.04. It's working. Okay. Add 1.27, and you get the next term, 7.31. Add 1.27, get the next term, 8.58. So 8.58. Again, you're adding 1.27. Then you add again. So add 1.27. 9.85. So 9.85, and there's your last two terms. So this one's arithmetic, okay? Because we have a common difference here. Okay, number 9. Number 9, what do we do here? So what do you, oh boy, figure out what you add to 5/2 to 5/3. That'd be fun to try. Maybe multiplication here. What do you multiply 5/2 to get to 5/3? So 5/5 times what fraction gives you 5/3? Well, it has to be 1 in the numerator. Excuse me. Not 1 in the numerator. We want 1 in the numerator after result. We want a 3 in the denominator, so let's put a 3 there. To cancel out the 2, we're going to put a 2 up top. Okay. So the 2's are going to cancel, and we end up with 5/3. So it looks like our common ratio from here to here is, R is equal to 2/3. Okay, so let me see. When you take 5/2, 5/3 times 2/3. So let me just check. 5/3 times 2/3, you get 10/9. Oh, it is working. So here you're going to multiply by 2/3. There's your common ratio. R. Common ratio. Okay, so it's geometric.
Will the following students please come to the counseling office? Victor Reyes.
All right, apologize for the interruption there. Okay, so what do we have? We got to multiply this by 2/3. So 20 times 2 is 40. 27 times 3 is 81, so you get 40 81st. And then you multiply the top by 2, so you get 80 up top, and you multiply the bottom by 3, and you get 243. So 80 243rds. Okay, it's geometric. The recursive definition is found by taking 2/3 times the one before it, which is a sub n minus 1. All right, let's move on. Okay, number 10. All right, given a sub 1, find the fourth term, which means we're going to find a sub 2, and then a sub 3, and then a sub 4. Fourth term right here. Let's highlight this. The fourth, whoa, let's try that again. Sorry about that. Let me select my highlighter. The fourth term is called a sub 4. All right, so here we go. We're going to find it in order. So starting with a sub 1. A sub 1 is 15. A sub 2, well, that's equal to 2 times the one before it. So 2 times the one before it. So that's 2 times 15, or 30. A sub 3 is found by taking 2 times the one before that. So 2 times a sub 2. Well, we already know what that is. It's 30. So 2 times 30, and that's 60. So again, 15 times 2 is 30, times 2 is 60, times 2 is 120, times 2, 240, and so on. A4 is 2 times the one before it, a sub 3, which is 2 times 60, or 120. There's your fourth term. And that's how the game is played. Here, this one says each term is the term before it minus 7. Well, starting with T1 is 11. So T2 would be the one before it, T1 minus 7, which is 11 minus 7, or 4. T3 would be the one before it, which is T2, or T sub 2, minus 7. And that's 4. T2 is 4. We just calculated it. 4 minus 7, and that's negative 3. T sub 4 would be T sub 3 minus 7, and that'd be equal to negative 3 minus 7, and that'd be negative 10. And that's how the game is played. So let's try it again. This one here, we're given a sub 1 is negative 7. A sub 2 is 11 minus the one before it. So 11 minus a sub 1. So it's 11 minus a negative 7, and that's 18. A sub 3 is 11 minus the one before it, a sub 2. So it's 11 minus 18, and that's negative 7. A sub 4 is 11 minus the one before it, a sub 3. And that's going to be 11 minus a negative 7, which is 18. So it's alternating, negative 7 to 18, negative 7 to 18, negative 7 to 18, and so on. Number 13, we have u sub 1 is equal to 3. All right, then u sub 2 would be equal to 5 times the one before it, which is u sub 1. And that's equal to 5 times 3, which is obviously 15. U sub 3 is equal to 5 times u sub 2, which is 5 times 15, or 75. Oh, you know what? Let me redo all that, because I missed the minus 6 part. So let me scratch that. I'm sorry. I didn't see the entire definition here. So u sub 1 is 3. U sub 2 is 5 times u sub 1, and then minus 6. You see, I missed this entire thing right here. Okay, so let me read carefully here, because I was going too fast. So 5 times u sub 1, which is 3, minus 6. 15 minus 6 is 9. U sub 3 is 5 times u sub 2 minus 6. That's 5 times 9 now, because we know u sub 2 is 9, minus 6. That's 45 minus 6, or 39. Use your calculator if you like. U sub 4 is equal to 5 times the one before it, u sub 3 minus 6. That's 5 times the 39, minus 6. Use your calculator if you want. Clear it out. 5 times 39 minus 6. That's 189. So that's last one here is, or the fourth one is 189. Number 4, we have a sub 1 equals negative 8. A sub 2 is negative 3.5 times the one before it, a sub 1. So negative 3.5 times negative 8. And that is, well, let me see. Looks like 26, but let me check here. Negative 3.5 times negative 8. Got to enter the right number in. Negative 3.5 times negative 8. 28. Okay, so 28. So a sub 2 is 28. A sub 3 is negative 3.5 times my previous answer, which is 28. And so all you have to do is keep on multiplying it times negative 3.5. I get negative 98 here. And then the fourth term here is negative 3.5 times the previous one, a sub 3. So negative 3.5 times negative 98. So again, on your calculator, you just keep on saying, pressing negative 3. Negative 3, yeah, 0.5. And you get 343. There's your fourth term. All right, last one, 15. B sub 1 is negative 6. B sub 2 is 3 times the one before it, so B sub 1 plus 4. So 3 times negative 6 plus 4. That's negative 18 plus 4, or negative 14. B sub 3, oops, sorry. Let me get back to the problem. B sub 3 is 3 times the one before it, B sub 2 plus 4. So it's 3 times negative 14 plus 4. It's negative 42 plus 4. It should be negative 38. Last one, B sub 4 is 3 times the one before it, B sub 3 plus 4. So it's 3 times negative 38 plus 4. Enter that in the calculator if you want. So negative, 3 times negative 38 here. All right, plus 4. Make sure you press the right buttons. Negative 110. All right. Now the only thing we need to do is the last 4. Just write the recursive rule. And let's go for it here. Next term, A is 7 more than plus double, all right, that means times it by 2, the previous term. So A sub n is 7 more than 2 times the previous term, so 2 times A sub n minus 1. Or you can write it as 2 times A sub n minus 1 and then add 7, either one. The order here, because of the addition, doesn't matter. Okay, number 17, we've got the common pattern R, the common ratio, is the difference between the last term and 4. The difference means subtract. Difference of the last term and 4. So the pattern R, that's your variable. So instead of A, we're using R. So R sub n, instead of A sub n, is the difference between that and the last term. Is the difference of the last term and 4. Last term and 4. So R sub n minus 1 minus 4 all over 11. All divided by 11. Okay, next one, the next value, u. So we're just switching variables here. Okay, from A to R to U, back to A again. Is the product times, okay, of the last 2 terms minus 5. Okay, so product means you got to multiply the last 2 terms. So u sub n is equal to the one before it, u sub n minus 1, times the one before that, u sub n minus 2, and then minus 5. Pattern A here is the sum. Okay, so A sub n is equal to the sum of the last 2 terms. So A sub n minus 1 plus A sub n minus 2, and then times it by 3. Let's just give it a hug. All right, and that's all there is to it, guys. You just got to get used to writing it recursively. All right, and like it's a video, all right? So if it's a video, you can always pause, play, rewind it, and listen to it again. And there's your recursive homework there in section 9.1. This is Mr. Ainsworth. I'll see you in my next lesson. Bye-bye.